We left off yesterday. So yesterday we stopped right at the power reducing formula. Okay. So when you get higher level trig functions, something to the third power, to the fourth power, to the fifth power, we have to have some way to reduce them to more manageable things, down to our squares, down to our single units. All right. It's kind of like, remember before when we said about like square roots, you can't really have a square root on the bottom of a fraction. You can't have this and you can't have that. One thing we're moving towards is you really don't want any trig functions higher than the first power. Okay, it's harder to comprehend what's going on if I have a tangent squared. I can see what a tangent is. I can see the relationship in the triangle, but a tangent squared, not necessarily. All right, so what we have here is power reducing formulas. These are for sine, cosine, and tangent here. So you notice each one of those, like sine squared, you could take a sine squared and take it down to a single unit of cosine. Now, it's also with the double angle and half angle, those things that we've been talking about, but at least it gets into a first power. Now, what we're going to do, we're going to reduce the power of a trig function. We're going to start with the cosine to the fourth power of x. All right, and we want to rewrite this so there's no powers greater than 1. Okay? So everything is going to be sine, cosine, tangent, those types of things. Now, our powers that we just looked at, they only go up to squares, correct? So let's go ahead and rewrite this as a square. So how could I rewrite the cosine of 4x as a square? Yeah, cosine squared squared, right? Could do this. So now I have the cosine squared of x. And if I look up here, cosine squared of x is 1 plus cosine of 2 theta over 2, right? Or in this case, it will be x. So we'll rewrite this as 1 plus cosine of 2x over 2, 20 squared. All right? Now, we have everything squared, correct? So let's essentially distribute that square through. So I'm going to go with 1 plus cosine of 2x quantity squared over 2. All right, and I'm going to, over 2 squared. So if I square the top, I could rewrite this as 2 sets parentheses and FOIL, or just use the rules for squaring. Rules of squaring, square the first term. 1 squared is 1. Multiply the 2 together times 2, so plus 2 cosine 2x, and then square the last term, plus cosine squared of x. Now, 2 squared then is 4. Okay? So now we're to a point we got everything down. We have 1 cosine to the first power. We got 1 cosine to the second power. So we're making progress. We start with to the fourth power, right? All right. I'm going to have to come up here. All right, so from there, let's get rid of that big fraction. That's just kind of ugly because I'm looking at this right now. If I can isolate this term, I could replace then the same way we did before, right? All right, so I'm going to divide everything by 4. So that's going to give me 1/4 plus 2 cosine of 2x is going to be 1/2 cosine of 2x plus, and I'm just going to write this as 1/4 cosine squared of x. So now I no longer have the big fraction. I just took that 4 and divided each term by it. You guys all right with what I did there? The reason I did that is now I have that cosine squared of x in a place where I can rewrite it. All right, using the power reducing formula. I could have done it on top of the fraction, but then I have a fraction and a fraction. That's just not pretty. All right, so I'm going to replace it again. So now I have 1/4 plus 1/2 cosine of 2x plus 1/4. Now, cosine squared of x We just did it once, we're doing it again. 1 plus the cosine of 2x over 2. All right, so now we just simplify a little bit. Just get rid of that parentheses here. Kind of have to distribute through. So 1/4 plus 1/2 cosine of 2x plus, let's make this the 1/8. 1 plus the cosine of 2x. Let's make it easier on myself to distribute. Okay, so I just multiplied the bottoms. We'll go one more step here. 1/4 plus 1/2 the cosine of 2x plus 1/8 plus 1/8 cosine of 2x. Yep. Oh, I missed something here too. Sorry. Because this was. Did I miss it? No, we're good. All right. And then, is there anything else? I mean, I could combine the 1/8 and the 1/4. That's about it, right? So 1/8 and 1/4, that'd be 3/8 plus 1/2 cosine 2x plus 1/8 cosine of 2x. All right, there we go. All right. You want to get that, Emma? All right, so there, I was able to rewrite that to get to a point where I only had powers to the first power. Okay? Questions on that? Anybody? Good luck. You're not going along for support? Okay. Or for lunch? All right, question. All right, questions on this one, guys. Okay, all we did was replace, simplify, replace, simplify. Okay, that's all we really did there. All right, you will have to, in your homework, take one or two of these and rewrite it in as a first power. Okay.
I don't understand why you can't combine the 1/10 and the 1/8. Like, why can't you just
Here and here.
like the cosine just
You could, and oh shoot, you know what I did? I made a mistake. 'Cause right here, this is cosine 2x. That should be 2x. 2x. That's good. That would be 4x then. That'd be 2 times 2x. Whoop, crap. There we go. That's why you can't combine them, because they're not the same. The way they were, you could have combined them. Good. All right, so right here, from here to here, I eliminated that 2x when I squared it. It should be cosine squared of 2x. I just had cosine squared of x. So there was a 2 that I didn't carry along here, making that 4x. Okay, no. Yeah, there's still an exponent there. It's cosine squared of 2x. I missed it from this step to this step, making that the final one is a 4. That's the only difference. Okay, that's the only thing that changed, and that's why you can't combine them. The way it was before, when they were both cosine 2x, you could have added 1/2 and 1/8 together. Yes, yeah, because it would have been like term. Yep. All right, so next one. Yeah. Be cosine of 2 times 2x. Like right here. And then cosine of 4x. I just multiply the 2 and the 2. Okay? And then I just carry that 4x the rest of the way through. All right, so we did, first thing we did was double angles, right? we were able to find some different angles using double angles. It would be able to do the same thing with what's called half angles. All right. So half angle formulas are right there. Sine of a angle divided by 2. All right. And it's not just find it divided by 2. You have to apply some formulas for it for the different ones here. So sine, cosine, tangent, those are the formulas that go with it. And just note then that the plus minus symbol in each does not mean you get 2 answers. It means you must determine the sign of your trig function by plus or minus based on the quadrant in which the half angle lies. That comes back to our all students take calc thing to go around through the 4 quadrants. All right, so we won't do a proof type 1 here. We'll do an easy, straightforward one. So we want to find the exact value of the cosine of 112.5 degrees. And that one sounds pretty ugly, doesn't it? Obviously not on our unit circle, is it? But what would be on our unit circle? 15, 112. We're close, but we just said about half angles, right? 112 is half of what? 112 is half of 225. So I can rewrite the cosine of 112 and a half to the cosine of 225 over 2. Now we have something that's on our unit circle. Okay? So again, by doing this half angle and double angles, we basically, when we did double angles, we doubled the amount of things that we could do on the unit circle, essentially. Half angles, we essentially double the amount of things that we would have on the unit circle. Okay, so each one of these tools is expanding and letting us use the unit circle to find more exact values of more angles, other than what's just on them. All right, so this is cosine. So for cosine of alpha over 2, we're going to have plus or minus 1 plus the cosine alpha over 2. So let's use the formula and rewrite. So we are going to have the square root of 1 plus the cosine of 225 over 2. Now, let's just think about this for a second. Where is cosine going to exist? Let me rephrase it. Where is the cosine of the original going to exist? 112. Where's that going to be? All students. It's right here, right? So is cosine positive or negative in that quadrant? Negative. So we had to make a negative out front. Okay? If it was sine, it would be positive. See how I did that? Okay, so we have to decide plus or minus. All right, the problem doesn't decide it. We have to decide it whenever we put it in. So because it's in quadrant 2, it'd be over here. It's going to be a negative. All right, so then we just roll. That negative just tags along the outside anyway. So we have the negative of 1 plus, what's the cosine of 225? Negative root 2 over 2. And it's all over 2. All right. So let's try to simplify this guy a little bit. Because I'm going to have a fraction over a fraction inside the root, aren't I? So what if I multiply everything by 2 inside? Can I do that? As long as I do it to everything, right? Okay. So I'm going to multiply everything inside by 2. So that's going to give me 2 plus my negative root 2 over 4. Because the other thing that does, that allows me to get rid of that root on the bottom, right? Because what's the square root of 4? 2. So on the bottom I have a 2. And on top I end up with this. 2 minus root 2. Boy, that looks ugly, but I can legally leave it like that. don't have a root in the bottom. Can't simplify that any further. That would be an exact value of cosine of 112.5 degrees. Nope, I'm stuck. I mean, we could do some crazy stuff, but I don't think you want to do all that. That's an acceptable form right there. All right. Any questions on that one? Same thing. Applied the formula, plugged it in, simplified. Of this guy? Yeah, we can do that. Let's do this last one here, then we'll go back to that one. Okay? All right, last one, half angle formulas for tangent. We just talked about this up here. Here's your half angle formula, your standard half angle formula for tangent. Okay, here's some other variations, depending on where you're at. If maybe you want it in a different form or something like that, you could use different ones. Let's verify one here real quick, and then that'll be the last in the notes here. We'll do one more like he asked about. All right, so let's go. We want to verify the tangent of alpha over 2 is equal to the cosecant of alpha minus the cotangent of alpha. This one's not a hard one, I promise. Now, I like tangent better than cosecant cotangent. You guys agree with me? So let's manipulate that right side. Okay? Cotangent is a little more straightforward. All right, so cosecant, what's cosecant equal to? 1 over sine minus what's cotangent? Cosine over sine. Boom. All right? If you want to. All right. Now, do I have a like terms here in the bottom? I do. So I have the sine of theta is 1 minus the cosine, not theta alpha. Well, look at that, and look at this. Isn't that the same thing? So therefore, this will be the tangent of alpha over 2. Boom. You with me? It matched the formula? Yep. So then I was able to replace. Does it match the half angle formula? All right. Questions? All right. So you want to do one more with the power reducing thing, right?